Welcome to qnawire.
In this question, we have some excited atom transitioning down to the ground level, and we're given that it starts off at an excited level 2.58 eV above the ground state. So when it goes down to the ground state, the emitted photon must be the energy difference between the excited state and the ground state. So this will be just 2.58 eV. The wavelength of this photon we can obtain by equating this to hc over lambda. So lambda is equals to hc over the energy of the photon, where hc is 1240 eV dot nanometers divided by the energy, which is 2.58 eV. This gives us about 482 nanometers. Now to find the uncertainty in the energy of the photon, we use the uncertainty principle, right? For the energy time uncertainty, right, this must be always equal or be greater to h power over 2. Right, assuming that we are at the lowest possible uncertainty, given our delta t to be the time in which the atom remains at the level, right, which is 1.64 times 10 to the power minus 7 seconds. Right, we assume this is our delta t. So the delta energy, uncertainty in the energy, just be h power over 2 divided by this time uncertainty. This should give us about 3.22 times 10 to the power minus 28 joules. And if you want to convert it into electron volts, we divide by 1.6 times 10 to the power minus 19, give us 2.01 times 10 to the power minus 9 eV. Now we want to show how the uncertainty in the energy relates to the uncertainty in the wavelength. We know that E is equals to hc over lambda. If you are to bring in lambda over to the left, we have lambda times E equals to hc. Well, these two are constants. Well, these two are variables. Right, they can vary. So if you were to differentiate them, right, so apply the differential or find the differential of this equation, you get the lambda times E plus lambda dE, right, equals to the differential of this hc, which is a constant. Therefore this will be 0, right, since it doesn't change over time. Well, we can replace this small amount of lambda as the uncertainty, right? This will be delta lambda E. We want to find delta E over E, so we bring the other term to the right hand side and we divide E over, so be delta lambda negative over lambda, right? And if you take the absolute value, this is the expression that we need, right, for our equation. Now to use this to find the smallest possible uncertainty, the wavelength. Uncertainty, the wavelength, is given as lambda times delta E over E. Since we already have the delta E, just have to put that in, divided by the energy of our photon, 2.58 eV, multiplied by the original wavelength, which is 482 nanometers. We should get something like 3.75 times 10 power minus 7 nanometers.